Hello, everyone. Thanks for joining us for this technical session. So our technical session today is basically on the eTechlog book that's been developed by Emirates with the technologies that Couchbase has provided, which has taken a big leap in our digital and paperless journey towards an aircraft maintenance process for our engineering department. So while the airline operations took a backseat due to the pandemic last year, we at Emirates were busy utilizing that time for innovation and building a technical solution that can actually take a big leap in the aircraft maintenance space and making ourselves ready for the bright future that's ahead of us after the pandemic. So in this session, we are taking you through that journey, how we started our journey towards a paperless, digitalized world of aircraft maintenance by building an eTechlog solution, which is first in the world kind of a solution that's powered by the capabilities of Couchbase. Before we begin, a few words about us. Myself, Harish Gopidas. I'm a solution architect working with Emirates Group IT. I have over 15 years of experience developing and designing and architecting solutions and software systems for the airline and airport domain. I have Milinda with me. Milinda, a few words about you.
I'm Melinda Saranga. I'm senior software engineer in Emirates Group IT. So I have around 10 years experience in the software development side, and since 2016, I'm using the Couchbase databases. So the architecture design, my colleague Harish will go through. So over to you, Harish.
Thank you, Milinda. So this is our agenda for today. So before we jump onto the technical side of it, I'll walk you through the logbooks and what is the business use of logbooks in an aircraft and the challenges that we are facing in the paper-based techlog world. And then we will jump into the digital solution that for the problems and challenges that we have faced in the paper-based techlogs. And then onwards, we will look at the business values that the solution has added, after which we will jump into the deep dive into the technical solution architecture and the role of Couchbase and the features that Couchbase provided to make this solution a successful one. And we will conclude with the future and what is in store for us in future for eTechlog and Couchbase and Emirates and so on. So let's start with our step one. Basically, to understand what is this solution is all about and what is techlogs in aircrafts. So do you know that airline travel is one of the most safest travel means of all in the world? This is not by chance, but by the very streamlined and strict processes set by aviation authorities, airlines, to make sure that the utmost safety is being ensured and standards are met for the passengers who travel. At Emirates, we have one of the largest engineering division that makes sure of this maintenance of aircrafts and the standards are met with one of the largest fleet overall in the world. So at Emirates also, we follow these processes that make sure that the aircraft is always met with the highest standards of safety. And there are two concepts actually that processes that's actually helping aircraft's safety, which is basically the base maintenance and line maintenance. While base maintenance is all about maintenance of the aircraft at periodical intervals, line maintenance takes care of maintenance schedules that's between the operational schedules. One of the key parameters that's monitored in this space is the airworthiness of the aircraft. So how do we ensure the airworthiness of an aircraft during operations? So in this process, basically, during every sector of an aircraft, the pilot who is actually operating the aircraft records any issues, any technical issues, any defects that he sees during the operation in a paper techlog, which is a predefined format for recording defects. And these defects are key for the airworthiness of the aircraft. So when the aircraft reaches the ground, an aircraft maintenance engineers make sure that these defects are resolved before the aircraft takes off for the next sector. Similarly, there is another log which is for the cabin, which is maintained by the cabin crew. They report the cabin related issues. For example, if you have a chair is broken, or light is not working, or maybe your entertainment system is not working. These kind of defects that see in the cabin is being recorded by cabin log. So the maintenance engineer, when the aircraft is at ground, makes sure that all these defects are rectified, and then before the takeoff of the next flight, the maintenance engineer and the pilot agrees on the defects that's been sorted out and then does a sign off. So this record is a very key document that's been monitored by the aircraft civil aviation authorities. And there are 3 copies of this log, which is one is always kept at the aircraft. Second one will be kept on the departure airport. And the third one will be taken to the hub of this airline. So at any point of time, we should have this record at ground in case of any emergencies that we may come across to analyze what's been going on there. Now, this process, as you can see, is very manual and it's paper-based. And there is a lot of manual labor involved in this entire process. So what you can see on the screen at the moment is the aircraft log record or technical log, what I said earlier. So as you can see, it's a paper and it's been handwritten by the pilot, recording different parameters in the aircraft, the time when the aircraft took off, the time when it landed, the cycle of the hours that the aircraft has flown, and in addition to the defects that he has noted during this journey. Now, being handwritten, actually, this actually brings in a lot of challenges for us. There has been a lot of events when we lost information because of the handwriting. People were not able to understand exactly what is being recorded in the defects, and this actually involves a lot of cost of data verification. And when we entered into the ground systems, in effect, this is a highly, because human intervention, this is highly prone to errors, and it's a very labor-intensive process, as I mentioned earlier. So at Emirates, we are always looking for opportunities to improve our processes and introduce digital processes. Make processes digitalized as we go forward. EK engineering or Emirates engineering is no different in this. Emirates engineering is very tech savvy, and they were looking at different technical solutions that can sort out all these issues for them. So a digital solution was thought through from Emirates engineering to the Emirates Group IT. And after we have gone through different workshops and brainstorming sessions to arrive at a solution for this challenges that we are facing with the paper-based tech logs. So one of the solutions that we've been discussing, what we have arrived was actually replacing this papers into tablets. So when we make it into tablets, what we can achieve is basically we can streamline the processes around the recording of tech logs and cabin logs, and make sure that the users are entering the right values and right parameters are captured during this process. So when tablets are introduced, you can have the data digitally streamed to the ground whenever connectivity is available, and real-time data will be available on the ground rather quickly than the earlier process, which is actually done only after departure or when the aircraft arrives at a particular location. Now, this what you are seeing on the screen is actually the logical solution that we have suggested. So basically, it involves 2 tablets in an aircraft. One will be kept in the cockpit where the captain will be operating, and the other one will be placed in the cabin log. And these 2 tablets will be connected through a Wi-Fi hotspot. And when connectivity is available, that's when the aircraft arrives at the ground, the tablet actually makes use of the connectivity and reaches to the ground. So this is the logical solution that we suggest. Now the next So this is how it will look like when the process is actually digitalized. So instead of paper, we will use tablets for recording tech logs and cabin logs. So as you can see here, as whenever the aircraft is on ground, the data will be streamed to the ground seamlessly, and this helps actually the users to have the data entry processes that we were using in the earlier stages, to avoid that and have quickly available data on the ground. Now let's see the business values that this new process adds. So in the paper world, as I said, there has been a loss of data loss, and there was a lot of data discrepancies. Now the electronic world ensures that the information is captured accurately, reduces the errors. It improves the compliance of data quality because you can have validations on the data being entered and all that. And manual process, so it was a very labor-intensive process. The users used to actually manually calculate a lot of values and then arrive at the final values. So all these can be automated, and even the data to the ground can be automated with the new solution. Another key benefit that we are getting is faster availability of data, as I said earlier. So as and when the connectivity is available, the data reaches ground, regardless where the aircraft is. So with this solution, so we started architecting this particular logical solution that we proposed, and we were looking at the options that we have on different technology stacks that we can use. So one of the key challenges or key issues that we had during the solutioning phase was actually making use of the data available always at the tablets and keep it synced between each other using an offline database mechanism. And whenever the connectivity is available, the data needs to be available on ground. So to achieve this, we evaluated different options, and Couchbase being able to have the Couchbase Lite offline database capability. And we have actually digitalized the solution with the offline database capacity with Couchbase Lite in the past in Emirates, which actually serves in aircrafts earlier for catering solutions. So we have already had an experience of using an offline database mechanism with Couchbase. So naturally, we selected Couchbase as our offline database for the solution. So as you can see in the solution, this solution involves two different components in this entire solution. One is the tablets that's been placed in the aircrafts, which will be capturing all the data from the users, the tech logs and the cabin logs from the users. And there is a ground system which actually accepts all the data from the tablets, and the services, the background database is being actually handled by microservices written on the ground services. So on the ground services, as I mentioned, the Couchbase architecture involves a 3-node Couchbase cluster and a SIM gateway with a load balancer on top of it. And this data is being accessed by our microservices, which uses Java APIs actually to query the data and do the CRUD operations here. We have a desktop application which retrieves this data and displays it to the users for different reporting purposes. And on the air side, which are the tablets, we have a Angular-based Cordova suite, which actually works on a Windows-based tablet. Now, this Windows-based tablet is actually served by a Couchbase offline database using Couchbase Lite. And this Couchbase Lite database is actually running on one spin up by a Windows service, which runs and manages this entire database. And all the different Couchbase services like replication, data sync, and REST API controls are done by this Windows service. We have another Windows service on this architecture, which actually controls the network operations, which controls the Wi-Fi connectivity, the mobile connectivity, and the hotspot connections between the tablets. This ensures that the highly secured connections are only used for our communication between the tablets, or corporate Wi-Fi's are only used for connection. So and this validation is done by this network services, and we are ensuring that only specific URLs, specific SIMs that has access to our data centers are only getting connected to the entire infrastructure. So this is the solution architecture. And going to the next one, basically this details the Couchbase architecture that we have used. As I mentioned, we have this offline database that's running on the tablet eTechlogs and eTechlog tablets and the Couch Camellog tablets. The data is being captured first on the tablets, and the data is persisted on the Couchbase Lite databases. And the Couchbase Lite databases have connectivity to the SIM gateway on the ground and uses ground replication using remote SIM gateway mechanisms. And between the tablets, we are establishing an peer-to-peer data sync or replication between the devices between these two Couchbase Lite instances. And we have this actually ensures high resiliency because we have two different instances having the data sync between two tablets, and also ensures that disaster recovery mechanism is established in this setup. So from here, Melinda will take you through the features that we have used in Couchbase and walk you through how we have built a disaster recovery system and a highly resilient database in air using Couchbase Lite.
Yeah.
Over to you, Melinda.
Yeah, thank you for sharing. Thank you for the architecture walkthrough. Yeah, now let's deep dive into the implementation part. So here we can see we have used salient Couchbase features to address our key business challenges. So you can see here, first is the offline database, so which is there in our device, and the ground replication. So whenever the connectivity we detected, so normally when the aircraft grounded or before the departure, so the device, our Windows service that detect the connectivity available, and it start the ground replication. And the next is you can see the data sync, intra-device, peer-to-peer, and the remote sync. So this intra-device mean we are doing a device to SD card synchronization, because in any case of the device failure, so this is the mechanism to recover the data. So you can see that details in the next slide. And next one is the peer-to-peer communication. And this is for the device-to-device communication, because as earlier Harish mentioned, we are using two tablets in the aircraft. One is we are calling the eTechlog, and the other one we are calling the Camellog. The next is the remote sync. That means the data sync to the ground server. From the ground server, again, it syncs back to the other device. So even though the both the devices are not connected each other directly in the same network, the devices will be synced through the sync gateway. This is what we mean by the remote sync. And the another thing is that we handle is the conflict handling. This is the one major challenge we faced, and there are different ways we have addressed this conflict handling. And the next one is the document change listener. So this is a heavily used functionality we have used in the device to refresh our front end whenever the document, any information change. The moment we receive the change to the device, we are refreshing and showing to the user. And also same thing, same functionality we have used with the sync gateway for the desktop application. Next one is the document detail, which means the time to live. So whenever we need to keep only some set of old documents, history documents only. So whenever the documents are not required, so we are using this detail functionality of the Couchbase. So the next is the Couchbase server caching. So instead of reading again and again, so since the function feature is already available in the Couchbase, we are using the server caching to increase the efficiency of the application. Yeah. So here you can see this is the device application design. So the sync gateway with the 2 instances, and the Couchbase cluster with 3 query indexes, and which is the sync gateway's load balance, and also you can see the Couchbase Lite directly talk to the sync gateway, and here you can see Couchbase Lite to Couchbase Lite. That means device to device communicating. So there is a Windows service running in the each tablet. So they are starting a custom network. So once the network is created, both the device databases started to talk each other. And also there is a continuous replication with the SD card. So as this is a critical application to the business, we need a recovery mechanism if the devices is faulty or in any case of failure. So because we cannot lose the data. So in air, if the device is failed, so since we have SD card here, so and also the data communicating continues to the SD card, and it will be available in the SD card. So here you can see in the eTechlog and the cabin log. In the eTechlog, there is a UI application and also the Windows service, and the cabin log UI application and the Windows service. So it is same application, but we have done the based on the design, we have done the separation eTechlog and cabin log, which align with the peer-to-peer replication in the Couchbase. So one device start the listener, and the other device continuously push and pull the data. So these are the couple of features we have used in the Couchbase Lite. So first you can see the conflict resolution. So there are a couple of ways we have handled conflict resolution. These are the learnings. So you can see one way how we handle is the with the timestamp. So if when the same data modified edited by the both the devices, so we are giving the priority to the latest document. But based on the information, we have to do the custom handling also. So what we have done, device 1 and device 2, when there is a conflict, and we are giving the priority based on the information. And the third one is, you can see the Couchbase 2.8, which is giving a default conflict handling. So this also we have used in our device application with the Couchbase Lite. So next is the change listener. So as I mentioned earlier, we have used this one heavily because whenever the tablet 1 modified any information, that will sync to the tablet 2, and the moment the data sync to the tablet 2, we need to show that information in the front end from the usability perspective. So what we have done is we have used this change listener in 1.3, and we after migrating to 2.8 with the help of Couchbase team, we have implemented that for the 2.8 as well. So the moment the data received in the second device, it will refresh in the front end, and it will show the latest information in the UI application. So next is the security. So the Couchbase is providing the encryption mechanism. So we have used that the default encryption mechanism for the local database, which is sitting in the device, and also the SD card database, which is attached to the device. And also for the replication to the sync gateway, and for the and to the peer-to-peer, we have used the WSS, which is the secured WebSocket. And the next is the document, the time to live. So whenever the documents are not required more than 60 sectors, so it is a predefined. So if it is more than 60 sectors, we have set the TTL, and it will automatically get deleted. It will get automatically removed from the Couchbase, because the final goal of the eTechlog solution is to send all the captured data to our MRO system. So after sending data to the MRO system, we are purging the data from the Couchbase. So here also we have used the Couchbase feature. Yeah. So we have seen now how we have used the Couchbase features with the implementation, and also we have went through the architecture. So my colleague Harish will continue from here. Over to you, Harish.
So we have now built the solution and it's technically ready. What is next? The next phase in any airline, every product that's been used inside an aircraft has to go through strict testing and assurance that this software works very well within the aviation standards. So for this, we have to take this product to the aviation authority approvals, which is our next phase, which will be starting very soon. And that's from a functional point. What is pending in the technical, what is for us in the future in technical. So at the moment, the solution, as I have explained earlier, this is deployed on OpenShift on-premises data centers. The next phase is basically we are planning to adopt a private cloud in our entire organization. So we'll be moving this solution to the cloud. So this will be a major phase in our application that actually ensures that the product is highly scalable and available. What we have completed is the first phase of eTechlog. There are a couple of functional features that's been awaiting for us in the backlog. So we'll be starting off the functional enhancement as soon as we get the airline of aviation authority approval and roll out the first phase. And the fourth option or fourth item in this list is basically the analytical opportunities. Now we have the data available on the ground on our servers that are defect data, the historical defect data that all these systems will be sending. So with this, actually, we can start analyzing the kind of defects that we have and we are encountering on aircrafts and predict the model and then take necessary and precautionary measures and make sure that the airline operations or the aircraft operations are much more efficient. So that's for us in the future. So looking for a bright future, and we are moving towards that new challenges that's put ahead of us. And in this journey, Couchbase support has been very tremendous. We have faced challenges and we have overcome it together along with Couchbase's support. And we are one of the earliest adopters of Couchbase Lite 2.8. And then in this particular journey, especially Couchbase has been supporting us tremendously through the various sessions. And I want to use this opportunity to thank Couchbase's all the management and all the technical team members who has been instrumental in our achieving this goals of ours. Thank you very much. And thanks everyone who joined us to listen this technical story of ours of eTechlog. Thank you.